All right, here we go. This is the last and final problem in our Quest tutorials. That's number 11. And here we go. It's a little application problem. What it says is a semi-elliptical archway. Now, I gave a picture. Generally, we're going to draw a picture here because it asked us there's a picture here. But what we have is a picture of an archway. This is a very rudimentary picture of an archway. But it's semi-elliptical. Now, a lot of students, when they see semi-elliptical, they're like, what is that? What is that? Is it a circle? No, it's elliptical. Semi-elliptical means it's half of an ellipse. And this ellipse is located right here. All right? The archway is set on pillars that are 10 feet apart. So if you look at this right here, we have an archway which is 10 feet apart, right there. You can see the picture below, which I just drew. Its height is 4 feet. Okay, so the archway's height is right here, which can be 4 feet. Where should the foci, okay, be placed in order to sketch the semi-elliptical, once again, semi-elliptical arch, okay? The center is at the origin. Now, in order to figure this out, what we want to do is we got to figure out where the foci are, because what we know is if we can have that, all right, wherever these foci may be, okay, we can place them from the center or maybe from the sides of the pillars or the inside of the pillars. But whatever the case may be, is that when we find this, we know that the distance, all right, from one foci to any point on the ellipse, that distance, we'll call it D1, and the other foci to that, we'll call it D2. The distance, D1 plus D2, will be equal for any other point on this ellipse, okay? And that's what the cool property of ellipse is geometrically. All right, so let's just get that up there. All right, but that's why we're doing this, so we can make this semi-elliptical arch. So to do so, we have to figure out where the foci are. Now, in order to figure out the foci, when you're doing problems like this, should elicit a value, all right? Because there's 3 different letters that we use that are distance from the center. And the center we know is at the origin, okay? And these letters are A, B, and C, okay? These are very important. So when you're doing this, this can be very easy, very difficult, but because A is the distance from the center, all right, to the vertices. Now, if you don't know what vertices are on the major axis and are from the center to the end of the major axis. So right here, essentially, this is what A is going to be. Now, since the whole thing is 10, A has to equal 5. It has to be half of that. Now, B, on the other hand, is the distance from the center to the point on the minor arc, or minor axis. So vertices are major, can't spell, major axis, and B is the minor axis. So where's the minor axis? Well, this one is going to be right here because it's the lesser of the lengths, because A always has to be greater than B. Since A is 5, and we know from here to here it's 4, well, obviously B has to equal 4. B equals 4 in this case. All right. So A is 5, B is 4. I'll just take this 5 right here. So A is 5, all right, B is 4. Now the question is C. Now what is C? Well, C, once again, all right, if you watch the other tutorials, I've said this repeatedly, C is the distance from the center to one foci. Okay, one of the foci. All right, and so what we have right here is that's what we're trying to find. So how do you find that? Well, we have a little equation because it doesn't come from any of our other little equations that we know. What we have is this: C squared equals A squared minus B squared. Okay, and that is one of the equations that we know. All right, and that's probably a whole tutorial on itself, and I'm sure there's others out there that can explain this. But this is what we're just going to know and use. It's one of the fundamental equations for ellipses. So we're going to take C squared equals A squared, which we know is 5, minus 4 squared. And so we have 25 minus 16. 25 minus 16 is going to give us 9. All right, so C squared equals 9. Where that makes C equal to 3. So where do we have to place this? Well, from the center, the points are going to be, all right, 0. Oops, not 0. All right, so these are going to be, all right, from the right and left side, right there. I should use a different color so you can see. 3 units, all right, to the right and left of the center. So that means we're going to have plus or minus 3, comma 0 if we want to find a point, Or if you want to think, okay, how far is that away from the side? Well, you could also say, well, the foci must be 2 feet from each pillar. Okay? Because we take 3 minus 5, this is our A value, and we get 2, so it has to be 2 feet from each pillar. So right here to here, it has to be 2 feet, because the other part is 3. So that's another way of looking at it. Either one you probably could use to determine this. All right, maybe this would be better. All right, depending on whatever you want to do. So once again, key thing: identify what type of conic section are you using. And this one is elliptical. Identify the parts by looking at the drawing. What is A? What is B? What is C? That's the key thing. To find the foci, we really need to know what the C value is, and that's the key thing when you're talking about foci. Is what is the C value? And the C value is the center to one of the foci. And using this equation, C squared equals A squared minus B squared is essential in solving that. Okay. Well, that ends my last tutorial of the quest that I gave. So hopefully this you find it worthwhile. And it gave you some insight on how to do different problems dealing with conic sections, specifically with parabolas and ellipses. So, blessings on your future problems.